All right, let's talk about computer vision because it is taking an absolutely massive leap forward. We're not just talking about AI that can see pixels anymore. We're talking about AI that can actually understand the concepts inside an image. And a huge piece of that puzzle is a groundbreaking new model from Meta called SAM-3.
Okay, so let's just dive right into the core difference here, because this slide lays it out perfectly. On the left, that's the old way. If you wanted to isolate an object, you had to point, click, and drag over every single thing. It was a total pain. But now, look at the right. This is the new way with SAM-3. You just ask. You type all the striped cats, and the model gets what you mean. It understands the idea of a striped cat and finds them all for you, instantly.
So here's our game plan. We're going to start with that huge shift from just pointing at stuff to truly understanding it. Then, we'll look at why the old models were kind of stuck, and how this new idea of concepts is a total game changer. After that, we'll peek under the hood, see what it's doing in the real world, and then, we'll look to the future. And let's be super clear about this. This isn't just a minor upgrade, a slightly faster version of the old thing. What we're talking about here is a completely different way for AI to see and interact with the world. It really is a new era. This quote right here really gets to the heart of it. We are moving past just tracing geometric shapes on a screen. The AI is now starting to understand the meaning behind those shapes. It's kind of like the difference between an AI that can just trace a drawing of a dog and an AI that actually knows what a dog is. That's the leap we're talking about.
To really get why this is such a big deal, we've got to look back for a second. We need to understand what the old models couldn't do and ask ourselves, why wasn't just seeing pixels good enough?
And this timeline lays it all out perfectly. We started with models like YOLO, which were great at just basic detection. Drawing a box around something and saying, that's a car. Then the first SAM models came along and they could precisely cut out an object you pointed to. But SAM-3, that's the final step on this timeline. It's moving from just outlining shapes to genuine conceptual understanding.
Okay, here's a perfect example. Imagine you're watching a video of a safari. With the old SAM-2, you could click on one specific elephant and it would track that single elephant for you. Pretty cool. But with SAM-3, you just type the word elephant, and bam, it finds and tracks every single one of them because it knows what the category elephant actually means.
And all of this leads us to the big idea at the very core of SAM-3. It's a whole new capability, a new task they call Promptable Concept Segmentation, or PCS for short.
So what does that actually mean? In plain English, it means the model can find, outline, and follow every single yellow school bus or striped cat in a photo or a video just because you asked it to. You're segmenting based on an idea, not just a mouse click.
So the big question is, how on earth did Meta pull this off? Well, it's not magic, but it's pretty darn close. It really boils down to three key ingredients, all working together in a really smart way.
So let's unpack those three. First up is a smarter architecture. They just built a better, more unified model. Second is the data, and this one's huge. They created a revolutionary new dataset for the model to learn from. And third, they unified all the capabilities, detection, segmentation, tracking, into one seamless system.
Now this brings up a really important question, one that plagued older models. They would often hallucinate. They'd try so hard to find what you asked for that they'd just outline a dog and say, hey, this kind of looks like a striped cat, right? Which, leads to a ton of errors.
And the solution they came up with is just brilliant. SAM-3 has this clever little component called a presence head. Think of it like a bouncer at a club. Before it even bothers looking for the object, it just asks a simple question. Is this concept even in the picture? Yes or no? By getting that out of the way first, it massively boosts accuracy and stops the AI from seeing things that just aren't there. But of course, for an AI to learn concepts, it needs to see a ton of examples. It was trained on this new dataset, SA-CO, which has over 4 million unique visual concepts. To put that in perspective, that's more than 50 times bigger than any of the existing benchmarks. It's just massive. Now, you might be thinking, how could they possibly label all that data? Well, doing it with just humans would have taken forever. So Meta built this incredible data engine. It's basically this powerful feedback loop where one AI suggests a label, another AI checks it, and human experts only have to jump in for the really tricky cases. This human-AI team-up was so good, it more than doubled their annotation speed.
Okay, but this isn't just some theory locked away in a lab. All this tech is already making waves out in the real world.
So let's see how this thing is actually changing the game right now. And look, the numbers here don't lie. On that new benchmark designed specifically for testing concepts, SACO SAM3 more than doubles the performance of the last best system. That isn't just an improvement, that is a monumental leap forward.
And that raw performance boost, it's translating into some seriously powerful real-world tools. We're talking about smarter video effects on Instagram, AR previews on Facebook Marketplace that let you see if a couch fits in your room, and even wild uses in science, accessibility, and robotics.
Yeah, let's just zero in on robotics for a second. An AI that understands a simple sentence like, "Hey, pass me the green bottle," isn't just running a script. It's actually perceiving, understanding, and then interacting with the physical world. That is a fundamental change in how we can work with robots.
So what's the big picture here? Where does all of this lead? What does this new level of understanding really mean for the future?
What we're really seeing is this incredible shift. We are moving away from AI as just a simple tool that we use to classify things, and toward AI as a genuine collaborator, an agent that can understand what we want and then go and do it in the real world.
And that, of course, leaves us with one final and kind of mind-blowing question. A whole new frontier of possibilities has just been unlocked. Now that our machines can finally understand what they are seeing, we just have to imagine, what are we going to ask them to do next?